Hey guys, welcome to our second example video. Now, as you see, I've already got a lot of stuff written up here, so pause it and write these things down if you can. I'll go over and kind of talk about what's happening. So what we're going to do in this video is we are going to transform this function f of x to be this function g of x here. Now, if we see f of x, it's what we would call a continuous piecewise defined function, right? You see that it could be drawn without lifting our pencils, therefore it is continuous. And it's defined in all of these little pieces. Now, I'm not giving us a symbolic form of this function because A, it'd be way messy and annoying, and B, we don't need it. We have what we need here. Okay? This is essentially the same as connect the dots as a kid, right? Connect 1 to 2 to 3 to 4 and go from there. So what we can do is instead of trying to transform this whole function and go all over, we can identify these critical points, these points that define its graph, such as I have defined here, and we can just transform these. We can just focus on these points. If we move them, then we can reconnect our function. And this works with everything, right? When we're doing these graphs in this class, we don't have to be super perfect exact sometimes. So like if we had, say, x squared, we could use 0, 0, 2, 4, negative 2, 4, right? So we could use those 4 points, connect those, and similar to the absolute value we just did, instead of connecting them with a straight line, we would connect them with kind of a parabola. And so any function you have, you can identify some number of points that are unique and kind of help shape this function and get a rough sketch of that graph. Now, when we look at our equation here, so g of x is equal to negative 2 f of x minus 3 plus 1. Now, you may be like, negative 2 again, right? The reason I'm doing that is just because I only want to go from negative 5 to 5. I don't want to really make our graph huge. If I make it more than doubling, it gets really big really quick. So when we identify the order of these transformations, again, PEMDAS is kind of what we follow, right? Inside the parentheses are grouping symbols, then we do any sort of exponents, which aren't a factor in transformations, multiplication, division, addition, subtraction. So inside the parentheses, the first thing we have is minus 3. Since it's inside the parentheses, that means it is a horizontal transformation. Since we are subtracting, that means it's a shift. And horizontal transformations act counterintuitively, which means minus 3 is actually going to be moving us to the right 3 units. So our first thing is a horizontal shift, right 3. So that's our parentheses. Next, multiplication division. We've got our multiplying by negative 2 out here, right, which is a reflection and a scaling. Okay, since those are outside the function, outside the parentheses, those are verticals. So we have a vertical flip, a vertical stretch. Okay, these can be done in either order. It doesn't matter. That's why I have the arrow. That could be, you could say vertical stretch and then vertical flip, then vertical stretch. And we're actually going to end up by the end doing them just simultaneously as one thing because it's easier that way. And the last thing we have is our plus 1 outside. So plus means it's a shift. Outside means it's vertical. Vertical transformations act the way we think. So this is a vertical shift up 1. So we have all of our information. And what I've done is I've grabbed the coordinates of all of these points and I have them written down here. This just goes from left to right. So negative 4, 2, negative 3, negative 1, negative 1, negative 1, 0, 1, 1, negative 2, and 2, 2. Okay? Now, when we're doing this, we want to kind of have some kind of symbols. This isn't necessarily a special math symbol. It's just something that we're going to use, some kind of annotations that we're going to use to help keep track of what we've done. And so this first one, we're going to do this as slow and as everything included in singular steps as we possibly can, so it's very clear, and by the end we're going to try and do this as fast as we possibly can. So, let me grab my chalk. So, when we're doing this, we're just going to follow this step, these order, 1, 2, 3, 4. So, if I apply step 1, what happens is it's a horizontal shift, right 3. So this point here, negative 4, 2, completely ignore this graph. So we're at negative 4, 2. I need to move this point to the right 3 spots. So if I'm just going to the right, the 2 completely stays the same. But the negative 4, if I'm at negative 4 and I go over 3 spots, it goes from negative 4, negative 3, negative 2, negative 1. So we get the point negative 1, 2. Now, let's apply step number 2. Okay. Step number 2 is a vertical flip. Since a vertical flip doesn't affect the input and neither does a vertical stretch nor a vertical shift, this input is done. We know exactly what it is. It's -1. So the vertical flip takes a positive vertical value, or positive output, makes it negative, takes a negative output, makes it positive. So we just need to change the sign of our output. So our output was 2, so now it needs to be -2. Okay, now we move on to step 3. I'm trying to fit all this in here, so it's going to be a little scrunched in here at the end. I wrote too big at the beginning. Let's just fix that. Okay, so we know that our input isn't changed anymore, right? Because all of our remaining transformations are vertical. So for step 3, we're doing a vertical stretch. So what we're doing, because we're multiplying the output by 2, okay, so we just take whatever the output was and multiply it by 2. So -2 times 2 gives me -4. And lastly, again, our last transformation is a vertical shift. So vertical shifts don't affect the inputs. So that is still going to be -1. And now we're doing a vertical shift up 1 unit. So that means we're going to take this -4 and we're going to go up 1. So if we're at -4 and we go up 1, that puts us at -3. And that is all of our transformations that have been applied. So we started with our -4, 2, which was the original point on the graph here. And we applied our horizontal shift right 3, which took it from -4, 2 to -1, 2. Then we applied our vertical flip, which just changed the sign of the output. So we went from -1, 2 to -1, -2. Next, we applied our vertical stretch, which is just doubling our outputs. So we went from -1, -2 to -1, -4. And finally, we did our vertical shift up 1, which just took the output up 1. So we would go from -1, -4 to -1, -3. And that's our final point. So what that means is if I put -4, if I look at the point -4, 2 in the original function, that corresponding point in this transformation will be the point -1, 3. So I stole some of my daughter's colored chalk, so this might be a little nicer. So we go to -1, -3. Okay, we have our first point there. Let's do that exactly the same way on this next point. Okay, so we're going to start with our first transformation, which is a horizontal shift to the right 3 units. So if I'm at -3 and I go over 3 units to the right, I'm at -3, I go over 1, 2, 3. I'm now at 0, -1. If I apply the second transformation, our vertical flip, okay, our vertical flip just takes the output and changes its sign. So if we were at 0, -1, our output is the only thing being changed, so we're still at 0. But instead of being at -1, we're now at +1. Now step 3. Okay, step 3 is our vertical stretch. So that's taking that output and it's doubling it. So we were at 0, 1, so doubling that output, doubling 1 gives us 2. So we're now at 0, 2. And finally, our final transformation our final step of this graph is to do a vertical shift up 1 unit. So if we were at 0, 2, and we want to go up 1, vertically, that only affects the output. So we are now at the point 0, 3. 0, 3. Okay. Now, there's a couple things. There's one thing I want to mention on this next step here. We can do our first step. Step 1 is a horizontal shift right 3 units. So if I was at -1 and I go to the right 3 units, I'm now at 2. Now this point here provides us with a unique opportunity. because we already know what happens to an output of -1, right? This has the same output as this point originally, which means when I apply the flip and then the stretch and then the shift, it's going to do the exact same things, which means I know that this point here, I can now apply steps 2, 3, and 4 all at the same time, simply by copying what happened here. And so this point went from an output of -1 to an output of 3. So I know this output of -1 is going to go to 3. So it's going to be the point 2, 3. Now, the reason I could combine all of those at once is simply because of the fact that we already did that, right? That is not something that we can necessarily do, be like, oh, I did this one, it went to -3, so all of these are going to go to -3. Only because these 2 points have the same output that I know what's already going to happen when I apply all of those vertical transformations to that point. So we go to 2, 3. Okay, now I want to start combining some of these steps, right? The second and third step are easy to combine. Instead of making a negative and then multiplying by 2, we can just simply multiply by -2. So I'm going to combine those 2 steps. So we're going to do step 1 still. Our horizontal shift, right 3 units. So if we were at 0, we go to the right 3, and we are now at 3. So we're at 3, 1. So now I'm going to do steps 2 and 3 at the same time. So what I'm just going to do is I'm going to do a vertical flip and a vertical stretch. I'm just going to multiply our output by -2 in this case. So we're at the point 3, 1. So now we're going to be at the point 3, and 1 times -2 is -2. Okay. Now the last step, step 4, vertical shift up 1 unit. So we're just going to take that -2, we're going to go up 1. So we're at -3, or 3, -1. Okay. So let's sped up that process a little bit, right? We can speed it up even faster. Because if you notice, this first step only affected the input, right? The output was left the same. And the next step only affected the output, left the input the same. So why can't I do this both at the same time? Affect the input, then affect the output. Just jump it all into one step. So I can actually do steps 1, 2, and 3 all at the same time. And the way we do this, we just kind of think in our heads a little bit, right? Okay, step 1 is a horizontal shift to the right 3. So it's going to affect the input. It's going to take it right 3 units. So if I was at 1, I'm now at 4. But now instead of just writing -2 again and then doing step 2 and 3 separately, I'm just going to do step 2 and 3 now. So steps 2 and 3 were to multiply by -2, multiply the output by -2. So I take -2 times -2, and that gives me a positive 4. Our last step is our vertical shift up 1. So if we were at point 4, 4, we go up 1. We are at the point 4, 5. Okay? Almost done. We got one more thing to do. Now, this point here is going to be done in one step. The reason why is, again, we're lucky. Because what's the output here? 2. And that went to the output of -3. What's our output here? 2. So we know what it does, right? So just like what we did here, where we did the first step and then we combined the remaining steps because we knew what the output already did, we're going to do that again, but we're going to kind of combine them all, or just do it all at once. So, steps 1 through 4. Step 1 is a horizontal shift right 3 units. So if I'm at 2 and I go right 3, I'm going to end up at 5. So the input of this point is 5. Now the output of 2, we know 2 will go to -3. So that means I know this 2, output of 2, goes to -3. And there's all the points. So we have the point 5, -3. So now I've got these dots which are orange, which I can see on the computer here if I get really close, look just like the white points and don't look any different at all. So see how my dot's chalk did nothing. But we just connect them. Okay. Oh, now we can see some orange, yeah. So one thing that's really important to note with transformations, right? So now we've got it done. It's really important to note the overall shape and features of the graph never, ever, ever, ever are completely altered. And what I mean by that is our original graph had a flat spot. Our transformed graph will have a flat spot. Our original graph had a peak and then a valley and then went back up, right? So it went to this little doot. Our transformed graph will have some doot. It will either have a peak and a valley or it'll have a valley and a peak, right? If it gets flipped. We can see here we have this valley and then a peak, okay? Those things will always be there. I cannot emphasize that enough. If a graph initially looks like that and you do a transformation and it looks like that, you're wrong, okay? It will never lose entire features of that graph. They may get changed, they may get stretched out, pulled up, shrunk down, moved left to right, right flipped upside down, so increase becomes decrease and things like that, but they're still there, right? We can still recognize that it's there, okay? So, function transformations, pretty nice and easy, right? If you can just identify singular points, apply these transformations, your life gets really, really easy. So, really work on this, okay? If you are struggling with this, there's extra practice. If you go to the MyOpenMath, and we first open up that MyOpenMath, open our class, scroll all the way to the bottom, past Unit 1, past Unit 2, you will see a folder that says extra practice. Open that up. Those are paper activities that I normally would do in class with you guys that you have you work on in groups. But since we aren't doing it in class, we aren't going to do them. And I'm just going to give them to you as extra practice instead of kind of making you guys do them and submit them and mess with that. But go and look at that function transformation one. There's a lot of good ideas in there. The idea way this class is built initially is lecture, group activity, homework. So a group activity can sometimes fill in some of those gaps that you guys may have, some of these kind of things that you're struggling with. Okay? Now, there's one more announcement I want to make. Okay? I want you guys, I'm going to make this announcement early because probably some of you guys aren't watching this. So, look for an email coming from me. I'll make an announcement. With that, guys, have a great weekend. This is everything for function transformations. On Monday, I will be posting a quadratics function video and examples section, and that will take us through the end of next week. So there will only be one set of videos for next week, but the idea with that is that you can kind of stretch this transformations over the weekend into next week, kind of get some help from me when you work on it this weekend. And quadratics is just a kind of a nice meaty topic as well, so we're just going to lay that on you instead of putting too much. So with that, guys, have a great weekend, study hard, and I'll see you on Monday.